So this is an Eclipse 32 by 40 built around 1999, 2000. I've upgraded it to a PCI motion controller in the PC, and this is actually an Eclipse Pro. What we're going to discuss now only works on Eclipse Pros. It doesn't work on Eclipse XLs. Eclipse Pros have a servo motor, and the servo motor has feedback to the motion controller, so the motion controller knows where the motors are at all times. It's called a closed loop system. XLs only have a stepper motor. Stepper motors are open loop. You send signals from the PC to the motor, and the motor hopefully does what it was told to do. The difference is a lot in price between the XL and the Pro motors. But let's look at how to test a motor or some other features, inputs and outputs on an Eclipse Pro. So right here we've got Eclipse Cut, Eclipse Create, and Servo Design Kit, or otherwise known as WSDK. So if I start the Servo Design Kit, it's going to open a window like this. The most important button is System Information. There's also a menu up here that says Terminal, and we'll use that as well. So if I click on the System Information button, it brings up this spreadsheet looking thing, and it has actual position, reference position, information about home switches down here, the home, reverse, and forward limits. All right, right now this is static and it won't change, but if I click on edit and then I pick continuous refresh, now this spreadsheet is starting to flash. I'm going to move this over, and I'm going to click on Terminal, and it's going to open up this window. In this window, we have a command window where we enter commands. We have a reply window where the machine replies to us if we've made a typo error, or if we've asked a question, the answer will come down here. This section is for a program. You can actually write a program and run it in order to run the machine. We'll talk about that in a later video. So I like to use these two windows set up side by side like this. Whenever you're typing in this window, you always have to be in capital letters. So put the caps locks on your keyboard, so you're always in capital letters. All right, now here's an example of a simple command. So right now I've got ones in these boxes. If I want to clear that, I can type DP for define position, and I can put in 3 zeros, X, Y, and Z, separated by commas, and when I press enter, it will change those to zeros. Okay, so I've got my cutting head open, like I'm going to change the blade, which means I have access to the cutting head, which means I can manually turn it left or right. Like so, if I push it to the left like this, you will see that this number has changed. So if I turn it back to the right, the number is going to go down. If I turn it back to the left, the number is going to go up. That indicates that my feedback device, my encoder, is working on the motor. All right. One of the other things is that there's a home switch inside the cutting head. There's a home switch to tell this where the physical home is. So if you watch your machine when it resets or initializes, it will move the cutting head this way, and then it will come back and find the home switch and stop, and then it will make a correction so that this part on the cutting foot housing lines up with this part on the head. So if I close the head and I look down there, you can see that this line here will be parallel to this line here. You don't want it to be cocked off one direction or the other, or that's going to make a hook in your mat. So once it's reset, you should be able to eyeball it like this and make it line up like that, and then you can see that it's straight. That'll mean your hook should be good. Okay, so let's back to the home switch. All right, so if I turn this around, see on the screen here, we've got home switch, the home switch line, and they're all zeros. If I turn the cutting head to the left, when it's not on the home switch, it is a 1. When it's on the home switch, it is a 0. So there's only a little spot where it's on the home switch. Same thing happens with X and Y. We'll talk about those later. Right now we'll focus on the cutting head. All right, so I've kind of got it as close to straight as I can get it, eyeballing it. I'm gonna clear the counters. All right, now if I want to turn the cutting head on, I need to have the machine switch, the power switch. I've got to have that on. And then in this window, I have to type set bit 3. And when I type set bit 3 and I press enter, there will be a click. Now that is turned on the motors, the amplifiers. So the amplifiers are now feeding power to the motors. If I now tell it I want the cutting head or the Z axis to hold, I will type servo hold and then the letter Z, and I'll press enter. Okay, now you'll see this number down here changes. This is called the torque. This is actually a voltage, measurement of voltage, and just sitting idle, this much voltage is flowing to the motor. Now, if I carefully touch the cutting head, I can't move it anymore. Okay, it's resisting me, and it might make a vibration in your hand, and it might make a noise like okay. Now if I look on the screen at that number right there, while I'm turning the cutting head, see, I'm putting pressure on it and it's putting voltage to straighten it back out. And when I let go, it relaxes. It never completely relaxes to 0. So that's how I know the motor and the drive are working. All right. At the same time, see, I've told it to hold it at 0. Now we've got a line right here that says position error, and so if we follow that over here, you'll see that number. So I'm turning it and I'm forcing it out of location, and it's putting voltage back against me and pushing it back to 0. That's how a servo motor in a closed loop system works. So now we know that works. So now let's move the motor. Let's type in position relative Z equals 4,000. Okay, so I'm gonna press, that's 4,000 counts on the encoder. So I would expect when I do this, that 0 to go to 4,000. So first thing, I have to load the motion into the controller, and that's what I've done. No change there. Now I have to say do it. So BG for begin, and then Z, begin Z, move the Z, what it has been commanded. Okay, now watch the number over here. So it ran up to 4,000. And now my cutting head is turned from this location around to 4,000. All right, now I want the computer to take control of the motor and find the home switch for me. We did it manually, but we want the computer to do it. So I'm going to say find edge Z. So that's the command, find edge of home switch, Z. Nothing's going to happen when I press enter, but now I have to tell it to do it, BGZ. And when I do it, when I press enter, this number changed from 4,000 down to that, and the cutting head moved a little bit back, and that's the physical location of the home switch. All right, so now the last move would be controlled by your hook setting, and your hook setting would take the cutting head and move it over to this location and straighten it up. So that's how we test the cutting head motor. If we wanted to know what to put in our hook setting for, a good guess, let's just zero out the position where it is now, DP 0, 0, 0, and now I've got 0 there. Let's turn the motor off, MO. Now I can manually move the cutting head. So I'm going to turn the cutting head around until I think it's straight, looking at it this way. Okay. And then I'm going to go up here and I'm going to see what this number says. It says negative 2927. So that I would write that down, and I would make that my first guess at a hook setting. All right. So let's just go do that. Let's turn the amplifiers off. So clear bit 3. Because we did a set bit 3 up here, we need to do a clear bit 3 down here to turn it off. All right, now I can exit out of this terminal, and I can exit out of the servo design kit. And I can open the Eclipse software. And I like to calibrate with a 16x16 mat and add an opening and make it 1 inch in the middle, and that way all my margins are the same. And then I send this to cut, and the first thing it says is, do you want to initialize? Well, I don't want to initialize right now. I want to change a setting first, so I'm going to say no. I'm going to go to setup and settings and hook, and I'm going to put in negative 2977. Okay. Now the machine's going to reset. Okay, so I'm going to click the OK button while we're watching. Oops, I don't have my air pressure turned on. Just a minute. See that little error message right there? Do you have air? My answer is no, so I gotta go fix that. Be right back. Okay, so we've made our sample mat over here, and we've sent it over the cut software, and we had an error. We didn't have our air turned on, so we turned our air on, and now this cut button is not highlighted, it's gray. So we have to use the setup menu and click on reset to reset the machine. All right, so now our cut button is hot and we can press cut. Now what happened when we did that reset? Let's do that again. Let's watch the machine. Okay, so did you see that little pause when the cutting head was turning back to the right? Let's watch that again. So pause, that last move, that's the hook setting. That is caused by setup, settings, hook, that number right there that we put in it. Okay, So that's all about the Z-axis. We can test all the other motors the same way.